stops recording. Okay, so our phone should be up. I am recording. You made these changes. I've checked up through 28. The rest of them are good, so you should be good on this part of your thing. I will double check the 12 before tomorrow. So what we're going to be doing is starting with number 8. We skipped it, if you remember, yesterday. And then we'll go on to number 11. And we're going to go up through, I can tell you exactly how far we're going today, up through 22. So we're not going to finish the blue packet today, which is totally fine with me. We'll finish it tomorrow, and then we'll start, I doubt we'll get done with, we'll start the calculator portion and finish on Friday. And then Monday will be our FRQ. Monday and Tuesday will be FRQs. So just like yesterday, I'm asking you guys to make sure your phones are put away, you're not on your laptops or doing other things, you're not, working for another class, sleeping. You're staying with me, asking questions as need be. I'm not rushing. I don't want you guys to feel rushed. That's why I don't mind taking another day. I want to make sure you guys understand these. And but then remember, you don't have any homework, okay? So you stay with me during the class period, and then you can forget about me when you leave, okay? When we get to the FRQ review, we're going to review the FRQ because we need a lot of practice in the FRQs. I think we all would agree on that, for most of us, I think. So when we get to the FRQs, we'll review 2 in class, and then you'll have 2 to work on for the rest of class, and then as homework both days, okay? So lots and lots of stuff we get to use to practice later on. All right, so let's start with number 8, and please let me know if you don't understand or why isn't it this. Please, 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 I want you to, okay? And I am trying to record yesterday's video. Ann and Tammy got a little bit interrupted, so on any you got wrong, if you're not in the video, just let me know at some point and I'll help you, okay? All right, so in number 8, values of the terms of a geometric sequence are graphed in the figure above. Which of the following is an expression for the nth term of the geometric sequence? All right, we haven't seen these for a while. This is like at the beginning of Unit 2, so like in fall. This is a geometric sequence, and there's a formula that we had that looked like this. And this is on your formula sheet. This is one of the formulas you do. So the a sub 1 means that's your first term. R is your common ratio, and N is the term number. And we'll come back to that in a second. Okay, and when you graph a geometric sequence, it'll take on the shape of an exponential function. It makes like a J or a backwards J. So let's see what we have here. So again, this represents a geometric function. It's just graphed. So we have some ordered pairs, 2, 12, 3, 6, 4, 3, and that's enough. Okay, there's the first 3 points. So the way you're looking at this is that is a sub 2. The second term, a sub 2, is 12. This is a sub 3, and so on. Okay? And so if I were going to write out this sequence, I would say my second term is 12. My third term is 6. My fourth term is 3. I don't have the first term, okay? It gave me the second term. That was the first term they gave me was the second term. All right, so what we need is the a sub 1 and the r. We'll come back to the a sub 1. Let's start by finding the r. R is your common ratio. It's what are you multiplying by as you go left to right. If the numbers are getting smaller, that's going to be a fraction. If the numbers are getting bigger, it's going to be a whole number. So we know it's going to be a fraction. And if you can't tell by looking at that's 1/2, remember, you can go in reverse any 2 consecutive numbers and do division. Okay, so 3 divided by 6 is 1/2. 6 divided by 12 is 1/2. Okay, that means from left to right, we're multiplying. 12 times 1/2 is 6, and so on. Now, did we even really need to do that work on this problem? No. So one of the things we're going to talk about all the next month is smart test-taking tips, and one of them is about how can I save time. Before I even started doing this problem, what I should do is glance down, because I could save myself some time seeing that all of them have the same R, right? So I didn't even need to do that. Why did I do it? Because you might get problems that have different ones, so you have to know how to do that. All right, so we know we're going to have an R there. Now, we don't have a sub 1, and I just told you the formula is a sub 1 times r to the n minus 1. But that's okay. This is just like a generic formula. You can change this term to a sub 2, a sub 3, a sub 4. Just know that this number and this number match. So, for example, we could use the second term times r, and that would just change this 1 to a 2. Okay? And that's what we did. Our second term is 12 times 1/2 to the n minus 2 would be that one. Okay? So let the multiple choices help guide you. 3 of them had a 12. That's why I kind of looked at that one. Right? If you needed to find your first term, though, you would just multiply by 2. So 12 times 2. So 24 times 1/2. You could go backwards. Like they could have put 24 in there, and then you would have 24 in the front and a 1 up here. Okay, so you could do it with any term. All right, we did 9. We did 10. I don't know why I skipped 8 yesterday. I think I thought there was another one like 8 in today's math problem, so I wanted to do them in the same day. But there wasn't, so I don't know. Who knows why I did that. All right. Here we have a polynomial g, and we have to decide which one of these expressions matches up with g. So what we have here is a polynomial that's in graph form. It's a graph, okay? Told us it was a polynomial in graph form. These are polynomials in factored form, all the parentheses. Yesterday we talked about a polynomial that was in standard form, written like this. Remember we talked about the end behavior and all of that stuff. So same idea. Let's kind of break down this graph a little bit. One thing I do notice is I've got end behavior that's up, up, right? And that is same end behavior. Anytime the end behavior is the same, meaning up, up, or down, down, our n, which is our degree, remember yesterday, is even. So we know we're going to have an even degree. If it's opposite, odd, opposite would be odd. So if you have 1 up and 1 down, you know it's going to be an odd number degree. So and then I also see 3 x-intercepts, okay? Now let's see what the choices are. So how do I tell what the degree is when it's written in this form? One thing you could do would be square the x plus 3 by FOILing, then distribute the x plus 5, then distribute the x minus 6, then distribute the 0.15, and you'd get an answer that would be in standard form. It'd be a ton of work. It would take the entire time that you have, and it's so unnecessary. What you really have to look at is any of these factors that have an x in it will contribute to your degree. In other words, there are 2 x's here, there's 1 here, and there's 1 here. So there's a total of 4 x's in that first one. Notice I didn't count the 0.15 because it doesn't have an x. That one, the 0.15 would change the number in front, the coefficient of your degree, but it wouldn't change the power. So 2 plus 1 plus 1. Same thing here. 2 plus 1 plus 1. That would be a degree 4. 1, 2, 3. That would be a degree 3. 1, 2, 3. Degree 3. So just knowing that one important fact, we can do a 50-50 here, right? We have an even number with A or B. So 50-50 at this point. But let's not stop there. Let's take it further. Remember those x-intercepts that we just talked about? Well, how I find those when I'm in factored form is set the factors equal to 0 and solve. So if I set x plus 3 equal to 0 and solve, I get -3. Here I would get -5. Here I would get +6. Let me just do this one. That would be 3, 5, -6. So looking at my picture, I have 2 that are positive, 1 that's negative. So that would be this one. And let's just take it one step further, even though we don't need it, but good picture and everything and time to talk about. What if they had the same? What if they both had 2 positives and 1 negative, okay, around the same numbers? There's one more thing you could look at, and that is your multiplicity. So multiplicity is how many of the same answer you have. So like we have a multiplicity of 2 for -3. This would be a multiplicity of 1 on -5, multiplicity of 1 of 6. We only have 1 of those. And if you remember, if your multiplicity is odd, in other words, 1, it crosses. Okay, it goes right through the x-axis. And if it has an even number power, it touches and turns, also called bouncing. So furthermore, looking at this one, we would have a bounce at 3 and a cross at 5 and -6. So this would be my 5, this would be my -6, this would be 3. So these are crosses. They go right through the x-axis, and at +3, it touches and turns, or bounces. So that's one more reason why B is your answer. Okay? Stop me if you need to. I'm happy to slow down. Okay. We also in Unit 2 did a whole bunch of work with logs, and one of them was rewriting this in an equivalent fashion. In other words, we expanded it, and it was using the 3 properties of logs: product, quotient, and power, and we'll use all 3 of them in this problem. First of all, you want to notice that in your parentheses you have a K, a W, and a Z, so 3 different terms. When you expand this, you're going to give log base 2 to each of them. So we're going to end up writing log base 2 3 times in this problem. Okay, so starting with K, that's just log base 2 of K. Okay, and then K is multiplied by W to the 3rd, they're multiplied, and multiplication and addition go together in log land. So I'm going to change it to plus. Don't forget to give everybody a log base 2. And you may be thinking, wait a second, we have to do something with that 3. I'll get to that in a minute. And then there's a division bar here, also known as a fraction bar. Division and fraction are the same thing. And you can think of division and subtraction going together. And I always think of that as a big subtraction sign to help me remember. And that would be log base 2 of z to the 2nd. So I gave everybody a log base 2, applied the product property, the quotient property, and lastly, I'm going to apply the power property, which tells us that if there's a power, you can rewrite it as a coefficient of the log. So this would be log base 2 of K plus 3 log base 2 of W minus 2 log base 2 of Z, which is B. So in the conversation we keep having about time, you know this is a time test. You also know your work doesn't mean anything. You can have the prettiest, loveliest work, show every step. Nobody cares. I mean, we care, but you know what I mean. So think about places that you can cut your time down on a problem like this that really isn't too difficult, and you could use that time on a problem that you need it. So, and here's what I mean. Like, we are such good, like, students. We have learned from all of our various math teachers, like, to show all your steps, and you like to do that too. Some of you are very thorough, but remember, and that's not a bad thing, I'm not criticizing at all, but remember, I mean, I'm not looking, nobody's grading this, we care about this. Can you get to this step, and this is just a rhetorical question, don't answer me, this is an individual question. Do I need to actually write the step in green, or can I look at the purple and know what I'm going to get and match it up with the right answer? That's up to you. Some of you, that's not how you work. You want to finish it in your writing, match it perfectly, that's fine. I'm just trying to remind you that you don't have to, okay? So just think about what you need to do or what you can do to save time here so you can use it on one that you need the time on, okay? Okay, we have another polynomial. This is standard form, right? No parentheses, no graph. And A and N are missing, if you noticed, and they are constants. Constants just mean a number, plain old number. N is greater than 2. Which of the following could be the values of A and N if the N behaviors is given to us by this limit notation? So we talked about this yesterday, if you remember, how to read this limit notation. So as x approaches negative infinity, which is to the left, our y values are going down. As x approaches positive infinity, which is to the right, our y values are also going down. So we have n behavior that is down, down, which is same, right, going in the same direction. So we know our degree, which we always call it n, is even. Okay, we just talked about an up one a second ago. So we know our degree is going to be even. Well, right away, we have a 50-50 chance, right? There's actually something else in this problem that is very poorly written that eliminates another answer without even knowing how to tell what the A value is. Does anybody see it? Instead of, what do you think it should have been? Yeah. greater than or equal to. She probably meant to put that because it says n has to be greater than 2. That means it can't be 2, right? N can't be 2 if n has to be greater than 2. So it's kind of a bad question. So let's finish it as if that was an option still. How do you tell if the leading coefficient is positive or negative? Well, the graph that we use as a reference for our even number degree, our same n behaviors, is the parabola. If you remember when we had odd or opposite, yesterday we talked about a line. What does a positive in front do? What does a negative in front do? So remember, if you have a positive a value in front of your x squared, it's going to be a smiling, happy parabola, up, up, right? Positive people smile. And if there's a negative in front, it's a sad parabola. Negative people frown, down, down. So we are going down, down. It's a sad parabola. So that would be D. Okay. All right, 14. We've got an exponential function. I'm hoping we recognize that, or at least we will know. And we have to answer a question about it. We have to figure out which one. So let's see, what are we talking about here? Is the graph decreasing or increasing? So remember what that means, going up or going down. Decreasing means your graph is literally going down left to right, has a negative slope, going down, okay? Increasing is rising left to right, or a positive slope. And then concavity. Visually, we know what that looks like, but in words, that would be concave up is a increasing rate. It has to put the word rate in it for it to be concavity. Okay, so remember we talked about how confusing it can be with increasing and decreasing. This is one of the reference sheets I put for you in the module I told you guys about yesterday, where I dumped a bunch of stuff where all the videos are and the keys to everything. And it says graphical behavior reference sheet. It's the one-pager I referenced yesterday, and it breaks down all the different possibilities of these graphs visually and in words. So if this is something that is tricky for you, I did put that resource in for you. What we need to know about exponential functions is that A is your y-intercept, and B shows growth or decay. If B is greater than 1, we are growing. Our data, our graph is getting bigger, increasing, okay? Growth, getting bigger. And if B is less than 1, we have decay, getting smaller, decreasing. In our word problem yesterday with the AI stock market price, the A value in a word problem is your starting amount. Remember, it was how much the stock was worth at t equals 0 years or whatever it was. So anyway, one more thing we would need to know is what kind of the general graph looks like of a exponential function. And they look like J's or backward J's. So if I were to sketch this, 1, 2, 3, 4, I would have a y-intercept at 4, and of course this is showing decay. B is less than 1, so my graph is going to be decreasing left to right. So just without even graphing that, knowing that fact, we should be able to exclude C and D, because that says it's increasing, and so this would go like something like that. So whether you draw it, I'm a visual person, I like to draw it, or you can see it in your head, you should be able to identify then that that is concave up. Decreasing, concave up. My back is killing me from sitting here like this all day. Okay, you guys are doing a great job. I know this is boring to sit here and listen to me talk. You're not even really taking notes. You're just kind of following along, so I appreciate your attention. The function h is given here. Sine of beta plus pi over 3, for who cares, which of the following is an equivalent form of this? So this is going back to when I told you you would have to memorize the sum and difference formulas for sine and cosine. Remember some keywords were like sine is social and cosine is shy and that kind of thing. So one of the things we learned when we did that was whatever's in parentheses, whether it's sine or cosine plus or minus, we always called the first one alpha and the second one beta. So just to confuse things, the test question has a beta as the alpha angle, okay? Don't overthink it. Beta is a variable. They could have put an x there, they could have put a y there, a t, a theta, sigma, any letter they wanted to, okay? But for the purpose of expanding this, I'm going to call this guy alpha, this guy beta, okay? And what we learned about sine is social. We start with sine of b, which is our alpha. And since it's social, he likes to hang out with other trig functions, not just himself. Remember, if it was cosine, we do cosine only with cosine. And then on the other side of your sine, it's sine and sine. Okay, so cosine of pi over 3. Notice there's my alpha, there's my beta. And with sine, we keep the sign. So whatever you see here is keep it. Cosine, we flip it, change it. And then this is the point, if you remember when I taught this to you, I was always worried that you guys would mess up right here and not know, do I put sine or do I put cosine? Here's what you want to remember, some facts. We're always going to have alpha and beta in that order. So it's going to be b and pi over 3. And we don't have any repeats. So I wouldn't put sine again, because then I'd be writing the same exact thing I see here. So I know to put cosine because now I'll have sine and cosine of beta and then sine and cosine of pi over 3. Because remember, the order of your alpha and beta never changes. Okay? Alpha, beta, alpha, beta, alpha, beta. All right. Take it a step further. We can plug in the values for cosine and sine of pi over 3. So pi over 3 cosine would be 1/2. And that would be square root of 3 over 2. And this is one of those moments. Oh, sorry. Did someone say that to me? I heard somebody say something really softly, but I don't know who was that. This is one of those moments. Do you, rhetorical question, don't answer me, do you need to write this the way they have it, which is 1/2 first, sine b plus square root of 3 over 2 first, cosine b? I mean, this is the same as this. Do you have to write it? Decide. Maybe you can go right from that to that, just trying to give you places where you could save some time. Another thing, someone shared 6th period that this happened to them. Like, how tragic, the only word I can think of, is that if you remembered the formula, you did everything perfect. You know the answer, but you picked the one with the negative by accident. I mean, it breaks my heart to know that. Like, not really, this is a mock exam, but he was like, that's exactly what he did. He had the right work, picked the wrong answer. So we'll be like reminding each other a lot leading up to the exam. Be so careful when you're matching up that you pick the one. Because sometimes the differences in our answers, as we've learned, are so slight that it's easy to get them confused. Okay? All right, here we have, this is something that was just on our last test. A polar function is given by blah, 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 blah. As theta increases on the interval of between 0 and pi, which of the following is true about the points on the graph of this function in the xy plane? So let me take a quick glance. What are they asking? Okay, are we above or below the x-axis? And then are we getting further away or closer to the origin? That's what we're trying to answer. So if you remember, we learned all kinds of things about polar functions. I mean, go look in the hall at the projects. They make circles and hearts and loops and dimples and rose curves, but that's on a polar graph, right, with the circles. We discovered that they're much easier to answer questions about these polar graphs if we graph them on the rectangular plane. Because really, we learned how to graph this back in Unit 2. This is just a cosine graph, up, middle, down, up, down 1. So if we graph it on regular XY chart paper, it's a lot easier to make some of these decisions. So I'm going to actually sketch it kind of nice for you because I'm a visual learner, plus I'm going to show it to you. But understand, if I were taking the test, and I wouldn't expect you to either unless you really wanted to and had the time, to make such a nice, beautiful graph like I'm about to. So think about how we graphed cosine or sine. We'd split our x-axis into 4 equal parts, which is 5 points. These are my quadrantals, okay? I remember cosine is up, middle, down, up. This has an amplitude of 1, so highest we go is 1, lowest we go is 1. But then we take all those points and go down 1. So if I take my graph of up, middle, down, up, and I move them all down 1, all that really does is, it makes it really easy to graph. I just call -1 my new middle, or x-axis. It just moves everything down 1. So I would do up, middle, down, up. Okay? So that's a sketch of that graph. Now, what are they asking for? They're asking for what's happening from 0 to pi. That's important, right? When we did this on our graph, a graphing calculator, we would change the window. Well, we're not changing window. We're just going to zero in on this part of the graph. What's happening from 0 to pi? Well, right away, whether you graph this or not, you probably could have pictured the graph, maybe, I don't know, and gotten to a 50-50. All of our points there are below the x-axis. So we're at a 50-50 shot here. Are we getting farther away or closer to the origin? Well, I think you guys can easily say that you're getting farther away, but let's talk about the y of it. In this problem, r is negative and our graph is decreasing. Remember, if it matches up, it makes sense. Like negative goes with decreasing, positive goes with increasing. Whenever that's the situation where the two match up, our distance from the origin is increasing, okay? It's decreasing when you mix and match. Like if you had negative with increasing or positive with decreasing, then you'd say decreasing. So our distance is increasing, which means getting further away. Okay? Solving a log equation. It's just solving a log equation. We have to solve for x. Look at all your choices. They all have x equals something. What we have to remember is, what is the base of all natural logs? Do we remember? Look at your choices. Does something stand out? E. Again, when we're getting confused, I mean, sometimes we can get good hints from the multiple choice options. Natural logs have a base E, always. You'll never see it written there. 10 is logs, common logs. If you don't see a number on the word log, it's a 10. All right, and the way we solve log equations is rewrite it in its other form. So this is e to the second equals the square root of x minus 5. Remember the arrows? 2 is the loner on the other side. He's also the exponent. Now I'm trying to solve for x, and x is trapped under the radical. So I'm going to get rid of it by squaring both sides. So e to the second, I multiply it power to a power. And when you square a square root, you're left with the radicand, which is just the stuff that's under the radical. And then the last step would be just to add 5 to both sides. So x equals e to the 4th plus 5. We don't need a calculator for this. We don't need to figure out what e to the 4th is. I mean, if these were in decimal answers, you would have to have a calculator to do this problem. Okay, but you don't need it because of the way our answers are written. Okay. Almost there, guys. We started working with statistics in Unit 2 a little bit, so we're going to touch on it here. We'll do more review later with these. But what we have here is some data that represents some projected sales for a saltwater fishing reel. Okay. The sales analyst used a linear regression to create a model. So I'm going to go over these words. Linear regressions create models for us. The figure above shows a graph of the residuals, different word, of this linear regression. Which of the following statements about the linear regression model is true? Okay, lots of words there, and not really comfortable words for most of us, including me. This statistics stuff is not my fave. But take a quick glance. Okay, we're deciding if the linear model is appropriate or not appropriate and why. It has something to do with the pattern, okay? So what a linear regression is, or any regression, is a model created from data that you give your calculator. So even though we're not using a graphing calculator, what we would have done to create this would have been go to stat, remember enter, and you enter a bunch of x's and y's. You're entering data, and then we would go to stat, and I'm sure we have to do this on the graphing calculator portion, so I'll go into that again later, and we go over to calc, and then you'd pick which REG, which is regression model we're doing. This one is talking about linear. Oh, thank you. Okay, this one is talking about linear, so we would have picked linear, and it would have given us a model, a slope and a y-intercept, M and a B, that we could plug into slope-intercept form that would model the data that we'd entered, okay? That's a regression. A residual is the difference between the actual and the predicted. So what actually happened versus what the model predicts will happen, okay? Remember, we would find the difference, we'd overestimate, whatever. What we're looking at is the residuals, that difference, a graph of that. And what we should notice here is that there's a pretty clear pattern, right? There is a pattern here, okay? But to be appropriate or not appropriate, what we want is no pattern. I don't know if this is the best way to say it. No pattern is appropriate. Yeah, that's a good way of putting it. So if there is a pattern, that's not appropriate. We don't want to see a pattern with our residuals. And this is a graph of our residuals. So just knowing that one fact, that this is a residual and it has a pattern and a pattern is bad, we would get a 50-50 chance. And it's not because it doesn't make a linear pattern. Your residual graph should not make a line. It should not make a parabola. It shouldn't make an exponential. It should look scattered all over the place. That's what we want. So the answer is it's not appropriate because there is a clear pattern. Not because of what type of pattern, but there is any type of pattern. Okay? So we'll touch on that again more in other reviews. Okay? Almost there, guys. I really like, there's two questions coming up I really like, and this is one of them. Let f of x equal that function, let g of x equals that function. So they give us two functions, and what they want to know is what is the x coordinate of where they intersect. Wait a second. We've done that a million times in our graphing calculator. If you remember, we'd put two equations in, we'd graph it, we'd go to calc, intersection, left bound, right bound, guess, yes please, hit enter, it gives us that x value. But we're not using a graphing calculator here, and our answer is not in decimal form, so we're going to be able to do this by hand. So think about it. When two lines intersect, what do they have in common is that point. What is the same? What is equal is the x and the y at that one point where they intersect. So another way of saying same is equal. If we set these two equal to each other and solve, we're going to get the x value that they have that's the same. So if they had intersected, that would be the x value that is the same for them, equal. Okay? So I'm just going to use my algebra skills to get my trig function by itself. The trig function is sine, cosine, cosecant, whatever. So I'm going to first subtract 1, divide by 4, and I'm going to use my unit circle knowledge to tell the test people where cosecant is -2. And of course, we didn't memorize cosecant. We memorized sine, cosine, and we know all our tan tricks. So we should be able to answer those three on any angle of the unit circle. Cosecant is not part of the deal. I did not tell you had to learn that. And we don't have to. We have one more piece of knowledge that we can use. And that is that cosecant has a friend, and his name is sine. If you flip cosecant, you get sine. Remember, every C needs an S. Seth, are you listening? And every S needs a cosine. Sorry. Too many S's. And Seth, come on, pay attention. So if I flip one of these, I get the other one, okay? So if I flip cosecant, I get sine. You flip cosecant, you get sine. I'm just doing it in words. If I flip the left-hand side of my equation, I have to flip my right side. Remember, you can do anything you want to an equation as long as you do it to both sides. So I'm choosing to flip both of them. And now I'm in familiar territory, and I can determine where do I have sine of -1/2. So that means that is what angle. What are my denominators where I have 1/2 or -1/2? I didn't even mean to write it so fast, but yeah, denominators of 6, right? Remember, this is sine. This is cosine. So I know these are going to be denominators of 6, and use all your tricks, guys. All students take calculus. Remember, this tells you where your trig functions are positive. So sine is negative where it's not positive, so that's there and there. So in quadrant 3, you add 1, and in quadrant 4, I say at 5, I go to 7, 11. Okay? Intersections set them equal to each other. On a graphing calculator, we will go over that again another day. Probably tomorrow. Right. All right, 3 more. And number 20, I don't think I covered number 20 by the time we took the mock exam. How many of you got this one right anyway? Just like smart guessing. A couple of you? Well, I bet you would have gotten this one right, because this is a really easy question had I taught it already. So you can't beat yourself up about 20, or I think 22 I hadn't taught yet, and it's easy. All right, so what we learned is that this is a polar function, how we match it up. One of the things we talked about is whatever the sign is directional, and the sign axis is up and down. So this is going to be an up graph, okay? So right there we eliminate those two. And then how far up do we go? Do we go up 8 or do we go up 6? And now that I've taught this to you, remember it's A plus B, so it would have been up 6. Add, not multiply, okay? You might also remember you go out, right, and left 2, but whatever. You would have all gotten that one right, I think. So you could almost count it right when you're grading yourself. Up to you what you want to do there. All right, 2 more. I love this question. I think this is such a great question. Okay, the number of people standing in line to cast their vote during the lunch hour can be modeled by the function here, so this cosine function, where t is the time since lunch began in minutes or 0 to 60 minutes. So for an hour, they took down data of how many people were in line to cast a vote. They made this equation out of it somehow. Okay, which of the following is the maximum number of people waiting in line to cast the vote? Okay, so think about this. I have this function. You don't have to write this if you don't want to. I'm going to write it in a way that's a little more familiar to us when we graph, and that's putting the 49 at the back. Totally optional to write this. I'm just explaining it to you. But that's exactly what was given. They just put the 49 in front, but the plus 49, we would traditionally have seen it at the back, okay? Something else I know about this graph, it's a cosine graph with an amplitude of 23 and a flip. Now, you certainly do not need to graph this. I'm going to sketch this graph just like I did with the other one to kind of make my point about this graph, okay? So without the 49, I'm just going to call this like my parent function, and I'm totally not caring about my x-axis at all, because really what we're caring about is how high or low. So really it's about the y's. But just a quick sketch of this. This would be amplitude of 23, right? And since it's a flip, instead of going up, middle, down, middle, up, we would start down. So I would have down, middle, up, middle, down. Okay, that's if the 49 weren't there. So if the 49 weren't there, we would say the maximum people in line would be 23, right? But that 49 says, oh wait, you're not done. You're going to move all of your points up 49. So I'm going to add 49 to 23, which will give me 72, and that will put my maximum point up there. Okay, so you had an amplitude of 23, and then you moved all your points up 49, and 23 plus 49 is 72. It's a really cool problem. I applaud whoever created it. You probably don't, but I like it. All right, last question. You're doing great. You're almost there. And this is an easy one. Did I cover this by the time we took the mock? Do you guys remember? Okay, so I bet you would have gotten this one right too if you didn't. Maybe you guessed it right. Because I know you guys haven't had polar with any other teacher, so it would have been a guess. All right, so remember, when we graph a point, we start out where it's positive. So 4, 2 pi over 3, that's quadrant 2, but the 4 makes us shoot through the origin, and we would have ended up here. So I'm going to call this P. Okay, so 2